So let's get going. This is our threat research roundup for the first quarter of 2026. We had a very busy quarter with a lot of research published here at Reversing Labs, and even more stuff that we found. We might have talked about it on social media, but not written actual research reports on it. NuGet toolkits, fake recruiter campaigns, ghost installs, cascading supply chain attacks. Yeah, all of that we're going to talk about. Why don't we start out by introducing our amazing crew of researchers here with me in the studio. And I will start with my colleague, Carlo Zanchi. Carlo is a lead reverse engineer here at Reversing Labs. Carlo, say hi and tell the attendees a little bit about what you do here at Reversing Labs.
Hi everyone, I'm Carlo. I work in the threat research team. My main goal is finding malware in open source package repositories like npm and PyPI and preparing research blog posts about that stuff. In other time, we do threat detection rules to catch that type of malware and similar stuff. House maintenance.
Thanks, Carlo. With Carlo is my colleague, Lucia Valentic. Lucia is a software threat researcher here at Reversing Labs. Lucia, you want to say hi and let the attendees know what you're working on these days?
Hello, I'm a threat researcher at Reversing Labs. I've been with Reversing Labs for 3 years now. As Carlo says, I'm also searching for malware on NPM and Ruby gems. And every day I'm trying to improve methods and techniques with which we are searching for malware and try to find them as soon as possible and flag them as malicious.
Great. And with Lucia and Carlo is Petar Kirchmeasure. Petar is a software threat researcher also here at Reversing Labs. Introduce yourself, and this isn't your first webinar, but tell the audience a little bit about the work you do here, Petar.
Hello, everybody. My name is Petar. I've been with Reversing Labs for 3 years now, and my main tasks here are monitoring NuGet and VS Code ecosystems.
Very cool. Okay. Thanks. We're really happy to have all of you here in the studio, and we got a lot, as I said, got a lot to talk about. Just a quick rundown of the agenda here. We're going to start out with some research. Petar, you did on with NuGet, and also an attack on the Stripe financial, banking, online banking app. And we're going to then talk about the Grafalgo. That's a campaign we saw return in the last few months. We're going to talk, Lucia, about the Ghost campaign that you wrote about, and then wrap up with the huge Team PCP cascading supply chain attack that really, impacted some really highly and widely used open source libraries and components. And talk about kind of how that played out and what we learned from that. We'll end, obviously, with some, best practices, key takeaways. This isn't just, picking over the wreckage from these attacks. We're really interested in helping you all to learn from them. And that's what we're going to do. And obviously, we'll end with Q&A, take your questions, and hopefully answer them. Okay. So let's move on. Start out, with, like we said, with the really interesting posts that you wrote, Tar, on some hackers' tools, scripting tools that we discovered. They appeared to have been published by accident, and they gave us some really interesting insights into some of the ways that malicious actors are kind of automating some of the behaviors that we've seen, particularly around kind of creating packages that seem to be more popular and widely used. But talk just a little bit. How do we find this attack? What initially triggered your coming across it?
Well, these tool chain, their main responsibility is to create fake packages, and one of their methods is to inflate the number of versions a packages has. And we are actively monitoring for packages like these. and the threat actors mistakenly, instead of artificially inflating the number of versions for a target package, they, I think, accidentally published this tool chain, which led us to actually getting to it and analyzing this tool chain.
So this was this tool chain, or the three components of it, which we call cloner, poster, and botter. I think they pretty much say a lot about what those three components did. Tell us, like, what does it kind of tell us that we have these tools for basically automating typo squatting of packages, and like how exactly did they work? If you could just explain that.
Yeah, well, as you said, the tool chain consists of three scripts, three parts. The first one is the cloner. How it works is you basically tell it to, hey, I want to scrape these packages that are popular, like Ethereum or Stripe. And what it does, it goes to the NuGet website, and it collects all the important metadata of that package: the package name, the package description, the icon, the number of versions, the number of downloads, all the interesting metadata stuff that you would want. And it does that for all the targets you set it to. And then it passes that data to the second script, the poster. The poster creates a new NuGet package, and using that metadata, it reconstructs basically the front page of the false package. So it uses the same icon, it uses the same description, the same repository URL, the same amount of versions, and it starts to slowly bump up its version numbers. So it posts one version after another until it reaches approximately the same amount of versions that the original package had. And once that is all done, it starts phase 3, the botter, which basically uses a PowerShell script that uses rotating user agents and rotating IPs to artificially inflate the number of downloads for this newly created package. So after the newly created package is created, it basically spam installs, spam downloads this newly package, so that it appears that this package has, I don't know, like 400,000 downloads, while in reality it may only have a couple of real downloads.
And to be clear, you wrote about this in February, end of February. This appears to be linked to a campaign that we wrote about back in December. Is that is that right? That was targeting Ethereum developers.
Well, yeah, we noticed that in that campaign, there were a lot of versions published in one day, which is unusual if you're a legit software developer. Usually, you would publish 2-3 versions per day max, and then take a rest. And what's also unusual is that there is like a huge amount of downloads in just 1 day or 2 days, which is for fresh packages, it's unheard of.
So let's ask the obvious question, which is those types of malicious behaviors are pretty consistent. You'd think that those are, those might be flags, red flags, or indicators for the platform owners and operators. NuGet, I think, is Microsoft, right, or whomever. But that generally doesn't happen. Why is that? And also, on the NuGet, that 2 or 3 years ago, we didn't see many malicious campaigns on NuGet. Now we're seeing more. Like, what is this telling us about, kind of the lack of security controls around some of these, open source platforms?
Yeah, well, first of all, the threat actors are spreading to every ecosystems you can think of, because, the greater their surface area of the attack, the greater the chance that they will actually catch a victim.
Yeah.
But coming from a defending perspective for Microsoft, yeah, they could put some more measures in place. For example, like I said, if a package is fresh and it has a lot of new versions in one day, like that's an immediate red flag. But that's on them to integrate. Yeah.
Right. So you also wrote in a somewhat related post about an attack, also a malicious NuGet package you detected targeting Stripe. Really interesting because we've talked and written a lot about attacks on, crypto currency infrastructure and applications, developers. Stripe obviously is not crypto focused. It's just a more established kind of commercial online payments app. Could you tell us just a little bit about the malicious Stripe package and again, what caught our attention about that?
Yeah, of course. Well, it was first it was like a typo squatted package. It imitated the original Stripe package. Basically, it contained same icon, similar description, similar URLs. But what was different was only the name. It had like, I think, .NET appended to the name. What was really interesting here is that the package actually contained the whole functionality that the original Stripe package has. So if you were to use this, you wouldn't even think that the package is broken or malicious because you would see nothing. But behind the screens, one of the package's functions was actually poisoned. And as soon as you load the package, actually, your Stripe API key would be leaked to the threat actor's database.
Wow. So really designed to kind of evade detection, right? And what would be necessary to detect a threat like that, where it's appearing once you execute the package, but not something you're going to spot just in scanning the package itself?
Well, you'd have to take a look at the package yourself. You have to decompile the binary and look at it, or use tools that already exist, like our products, Spectre Analyze, or the community Spectre Assure, that you can just use to check if packages are malicious or not.
And once again, with this package, we saw this just bloating of the downloads, 180,000 downloads in a very short period of time and so on. I mean, is that the type of thing that a developer, if you're sitting there about to download a package, you see it's got 180,000 downloads, is there an easy way to look and say like, oh yeah, like, all these downloads happened within the last, 36 hours or something like that. And so maybe this is malicious, maybe this is a scam.
On NuGet, I think if you go to the versions tab, you can see actually how the downloads were progressing through the versions, and you would actually see a red flag like, okay, this package has like, I don't know, 500 versions in one day. Each of them has like 100 downloads, and that totals to like 180,000 downloads. Yeah, that's kind of suspicious.
Right. And final question, anything that we should assume from the shift from crypto to Stripe? Should we expect malicious actors to be looking at more, non-crypto finance apps and so on as they expand their reach?
I think it's safe to assume that, yes, the threat actors will always try to find new ways to gain financial wealth. So either it be crypto or traditional apps like, I don't know, Stripe or PayPal or some other financial companies. I think those are all targets for threat actors.
We always assume it was kind of crypto because it was just a little bit more loosely managed, right? And flat, whereas the finance apps had big companies and a lot of resources behind them. I mean, that was always my assumption, but you see something like this and you realize, that might not be an obstacle for folks going on. Okay, let's move ahead.
Yeah, exactly.
Thanks, Petar. That was great. Okay, so the Grafalgo fake recruiter campaign, Carlo, you wrote about this. Super interesting. This is part of a very long trend of fake developer recruitment scams. These are almost all associated with DPNK, the Democratic Republic of North Korea, and Lazarus and so on. How did this first come onto our radar here at Reversing Labs, Carlo? And again, this was also a continuation of an earlier campaign. So tell us how we found this.
Yeah, basically, both Lucia, there are three blogs from this campaign covering this campaign. I wrote two of them, and Lucia wrote one. So it's not just my effort; it's the whole team effort. And basically, what we observed was malicious packages in open source package repositories, both in PyPI and npm, with the same name and same type of payloads. So that is something that is not so common, especially if you see that those are not simple packages, but the malicious payload is well hidden inside them. So we took a better dive and tried to wrap up the whole story behind those packages. Not, let's say we didn't want to stop, okay, these are malicious packages on npm and PyPI. We wanted to find out how were they doing malicious stuff and what was the whole compromise. That led us to front-end operations. Basically, the whole campaign is part of fake interview campaigns. They use fake job advertisements to attract developers, primarily related to cryptocurrency and blockchain technologies. And then they try to make them solve job offering tasks. And in that task, they plant malware in their systems. So basically, the whole operation is quite complex. It is modular. It had modular approach. So basically, threat actors have front-end operations, create fake companies. They even went so far to create a true legal entity in the United States, Florida, and then they create the entire front-end facade like LinkedIn profile pages and everything like that, fake recruiter profiles from which they contact post job offerings and lure developers to get in interaction with them. There are a lot of research papers about this entire fake.
Oh, you froze, Carlo. You still there? Oh, I think Carlos' connection is flipping a little bit. Really interesting. I mean, Pitar and Lucia, I'll throw this to you because you were, as Carlos said, you were both involved in this campaign, researching it. This is sort of, we've seen a lot of these, but the fact that they're going through the work of actually setting up a real LLC, a limited liability corporation in Florida, that maybe speaks to the fact that more people that the targets of these attacks are certainly aware of these fake recruiters, so they need to maybe do more to make the whole scheme seem legitimate, right? So, okay, this is Blockmerce LLC. Is that a real cryptocurrency? Well, yeah, I mean, they're set up in Florida. They got this, I can find their, official corporate records in Florida, and they got this LinkedIn profile, and it wasn't set up 2 days ago, and all this other stuff. So in some ways, is this good news, like a higher bar for threat actors to pull off these fake, development test campaigns, or not?
Sorry, I didn't hear the question from the beginning, but from the perspective, yes, they need to try more. That is definitely, but it's also a sign that this threat actor behind it is quite capable of doing really complex stuff. So,
Right.
however high you raise the bar, they are going above and beyond, I would say, and they are doing pretty decent campaigns. The last one think was Red Rift Protocol, something like that. They had people communicating in crypto conferences with other vendors, and
Right.
like the operations are lasting for months before they pull up the final attack. So
It's very interesting. Yeah, I mean, they're kind of engaging with crypto vendors as independent third parties, working with their building up relationships to the point where they get access, right, as part of this business to business interaction.
Yeah, and they're adopting the
and then
newest
it
tools
flips,
like
right?
AI
Right.
tools and everything like that. They have on their disposal to create fake identities and everything like that. They are truly breaking edge technology adoption in the whole entire campaign design. So it's a pretty respectable threat actor.
And as you said, this was even though this LLC and stuff were new, the back end of this campaign was basically the same as what we had documented before. Is that right?
Well, not
Yeah.
entirely. In the
Okay.
first wave of the campaign, the entire stuff was dependencies on open source package repositories like npm and PyPI. Now we still see dependencies in npm, so there is likely a front-end campaign we are not aware of. But the one we are monitoring, including new companies like Bridger Finance and similar fake companies, the attacker took another approach. They removed the second stage payloads, which are hosted as open source package repository dependencies, and moved those dependencies to GitHub. Why? Because there are so many supply chain attacks targeting npm and PyPI. A lot of companies are looking at that stuff, and malware gets quickly discovered there. But GitHub is huge. There are a lot of repositories, and nobody is thoroughly watching what gets published to GitHub. And I can say from my personal experience, GitHub is the most popular public source tool for these threat actors, because it's easy to put a release artifact into a repository on GitHub to create a typo spot, and likely nobody will get onto it for months because there's so much stuff on GitHub, nobody can look at all of it.
And Lucio, you did a deep dive on this campaign. We published that as a separate blog post. One of the things you pointed out was that the Grafalgo package mimicked this legitimate NPM package called GraphLib or GraphLib, which is a JavaScript library that was really widely used, 2 million, 2.5 million downloads a week. But one of these packages it was like 6 years since the last update, right? So widely used, but not actively maintained. It seems to me like we've seen that before. Like that is for threat actors, if you can find an open source library that's really widely used, but that is old and outdated and not being actively maintained, that is very helpful to you if you want to then, typo squat it and be like, oh, new update for this package that, hasn't been updated in 6 years. You're going to get developers to really, latch onto that. Is that a pattern that we see? I mean, is that something that malicious actors are targeting, these widely used but unmanaged or not actively managed libraries?
Yes, we have seen that the last year, because I think for malicious actors, taking code of a legitimate package that wasn't maintained for a long period of time, they can pass their own packages as continuation or as a legacy for those packages that people used. And of course, if some developer sees a new package that is maintained and it's new and was maintained recently, it maybe has more trust in that new package that is maintained a week ago than it has for a package that was last maintained 5 years ago. So they basically, for all the packages in Grafalgo campaign, they took the code from the legitimate package and they included their own malicious payload file hidden inside of that package. And then they called it from the official function that creates graph, which is the point of the package. And only that way you can actually trigger the malicious payload.
Right. And we observed some really interesting technical aspects of this campaign, in particular, like how the malicious component was triggered. Could you just talk a little bit about what was different or unique about what we saw there?
So malicious payload was included in a separate file that was added additionally, and it was called in a legitimate function graph, but it could only be executed with the past arguments, specific past arguments, because those were used for code foretold with some arguments, some random arguments that weren't specific for the malicious payload. Malicious payload wouldn't be executed. So basically, all those GitHub repositories that called on malicious npm dependencies created that graph with specific arguments. So malicious payload was basically executed. Those past arguments were used as basically a password for the obfuscation, and then the final stage was downloaded, which was rat that stole crypto and some sensitive informations, and also can allow malicious actor to take over your computer.
I was just
And that's go ahead, Carlos. Sorry.
If I can add the broader context, the initial vector for infection was fake job interview, and basically all these packages were included in that fake job interview tasks in the initial campaign as a dependency in a package.json file for that project. And in the latest turnout of the campaign, they switched the technique and moved from package.json, which is a small file relatively, to package log files. And how did they decide to do that? Because nobody looks at content of package log JSON file. It's huge. It contains node modules files which are expected, and they did a clever trick. They added the typo squad of a legitimate package. So basically, you have a legitimate package on npm that is called parse URL. And what they did, they just put into the package log file resolution not to resolve from the official npm repository, but to resolve from a GitHub repository, which they typo squatted and created their own. So that's a new technique, not new technique as the technique, but a new technique in this campaign, which we observed.
And pointing to GitHub as well. I think one thing you also noticed was that they were they did a lot of they faked the GitHub the Git log contents to make these packages look like they had months and months of commits and so on. And is that something we've seen before as well, going to that level of detail on a fake package?
No, that's a new technique observed also in this part of the campaign.
Yeah. And is there a way for developers who might be looking to download or employ one of these packages to tell, like, oh yeah, all of these commits were actually, loaded in at the same time. This is not months worth of interactions.
Basically, you can't tell for sure, but if you look at the usernames and GitHub users for those committers, you will see that those are only local users. Most of them will be grayed out and won't have counterpart on GitHub, so there won't be a public GitHub account for that. So that's a signal that something is off. If you see a lot of grayed out users, it's not so common. When you have projects on GitHub, you usually have committers that have GitHub usernames. Right. There are private repos, but when you have a public repo, it's not so expected.
And again, the big picture here is getting access to those developer systems, right? And then access to the organization that those developers may work for or contract with or what have you, so that you can carry out, more sophisticated campaigns around compromising infrastructure, stealing wallet content and stuff like that. Like, that's the big picture here, is owning that developer.
Yes and no, but mostly I think they are just trying to steal stuff. When you're dealing with cryptocurrencies, they are looking for wallets and extension wallet browser extensions, and they are looking for a fast way to steal stuff from them, and that's why they are. Again,
could be the developer's wallet, could be, this developer works for a crypto company, and then they've got access to this larger infrastructure. So now we've got thousands of wallets, right?
I think that primary motto is financial gain. Again, we can't say if they see opportunity that they won't take it, but I think it's just financial gain.
Sure. Okay, moving on to the next campaign. Let me just, for our attendees, if you got questions, if Carlo and Lucia and Tara are saying things that are getting your mind moving, use that QA feature. We'd be happy to answer your questions and hear your thoughts. We are also using the chat feature, so don't be afraid. We'll take your questions sometimes when they come in, sometimes at the end of the talk. So go right ahead. We're interested in what your thoughts are and what you have to say. Okay, so Lucia, the Ghost campaign, really interesting campaign. Maybe something that was kind of a pre-release campaign that we stumbled upon. Could you tell us just a little bit about that? In particular, some really interesting techniques that you saw involved with this, including fake install logs that made the people think that this was a legitimate package being installed.
So basically, last month there were a couple of packages that weren't that interesting in itself. They were downloaders, but we noticed them because they had post-install scripts, which again can be legitimate usage of post-install scripts, but we still always check those kind of packages. And here in those packages, even though I saw they were downloaders, I also saw that something very interesting would happen once the post-install script would be executed. So basically, after the package is installed and malicious payload is executed, the user or the victim precisely would get in their just fake NPM logs. Can you hear me? I think I'm frozen.
You broke up a little bit, but
okay.
Yeah, maybe just repeat that those last couple of sentences because we can hear you now. Yep.
So basically, once the malicious payload was executed, once the post-install script was executed, the user or the victim would get fake install logs inside their console. And at one point, there was also a fake progress bar that would indicate there would fake installation. And at what point the user would be prompted with sudo password. So he would have to enter that sudo password, which would then be used to execute the final stage that would be silently downloaded while the user is looking at logs. So he wouldn't see that anything is happening, anything malicious is happening. He wouldn't see that something is being downloaded. He would only see fake logs that don't mean anything, basically.
Right. And again, as Carlos said, these are mostly financially motivated. This also seemed to be a campaign that was targeting crypto assets. Is that right?
Yes, basically the final stage was also rat that was mainly stealing, among other things, but it was mainly stealing crypto assets. I think in the last couple of months or years, we have seen a lot of packages that are, a lot of them are stealing crypto assets, basically.
Right. Is there an easy way for a developer who's installing a package to be able to know that what they're seeing, displayed on the screen? I mean, in this case, you were able to find all that just in the actual code, right? So
Yes.
Presumably if you were to, so is the lesson you should be looking through that source code before you're installing, deploying something?
Well, it would help. In this case, it would be easy because there are only a few files, but I don't think it's possible for all the packages. So as Petar said, it would be useful to search some tools or search the packages if they are safe or not. But in this instance, I think the flags would be raised because you would see some errors of installation of some packages that don't exist, that don't have anything to do with your package. And you would also need to enter your sudo password, which usually doesn't happen with installation of npm package. So probably you could figure out that something weird is happening.
Should presence of a post-install script itself be a red flag for you, or
no,
not?
Definitely. Like in npm packages, scripts, install, post-install, pre-install scripts are a legitimate thing, and a lot of legitimate and official npm packages are using them. They are okay. Sometimes they are just writing things out, like thanks for downloading, thanks for installing this package. But for us, for threat researchers, there are indications that something could be weird, that something could weird happen, because install scripts for malicious actors are very interesting because they are executed upon installation. You don't have to do anything, they will just be executed. So they are very interesting for malicious actors to use.
Right. And you found some really interesting data information as you were looking through these packages that made you think this may not be ready for, as we say, ready for prime time, ready for release. This may be a test version of this malicious package that they're kind of trying out. Talk about that, especially since we did see from another company, JFrog, published some research not long after that seemed very similar in terms of what they were observing. So did we stumble across a kind of test package here in this, as this campaign was being stood up, designed, developed?
So basically, I discovered, I think, 5 or 6 packages, and they each had multiple versions. A lot of them didn't have a functional second stage, and a lot of them had debug messages that probably help developer to understand what is happening, so he or she can test it more while it was developed. I think only in 1 or 2 packages I was able to find the final stage. So probably that was just a test run because I discovered those packages a month before I wrote the blog, but because of the work I couldn't wrote. So JFrog, a month later, after those first packages were published, discovered new packages that were that had similar infrastructure, but the final stage was the same, and they also used fake console logs to indicate that something is happening to fish for sudo password, even though they were downloading hiddenly red final stage.
Interesting, really interesting. Okay, let's just move along. I want to talk about the Team PCP. So this is a malicious actor, cyber criminal group that carried out a pretty jaw-dropping supply chain attack. And we wrote about it, others did as well. This started with this attack compromise of Trivy, which is a security scanner, but a lot of ripple effects after that. So let's just talk about how did we first, and I know all you kind of worked on this, but how did we first become aware of this compromise of Trivy? I don't know, Carlo, do you want to start?
Yeah, well, basically the Trivy, the compromise content was GitHub Actions. So we do not monitor GitHub Actions, and we found out from open source intelligence as everybody else was picking up on it, and we started tracking the whole campaign and discovered checkmarks OpenVS6 packages. We reported them like many other vendors did discover, and also the Telnix packages, which later, and the LightLM PyPI package also was not that hard to spot because I think even our automated system detected it. The problem with the whole cascading supply chain was that people use GitHub Actions in their CI/CD workflows. And a lot of people are doing it in unsecure and improper way. And basically, the simplest hygiene is to pin the actions you use to hash, not to tag. And the main reason why this worked was because this was, let's say, a tag poisoning, call it however you want. They managed to compromise the credentials to point all the release tags except one to a malicious commit. And what that means, every upstream project using your GitHub action and referencing by tag will download the malicious version, which was, let's say, you had tag pointing to legit version. Now somebody deleted it and redirected it to malicious version. And the whole problem is that the workflows and CI/CD infrastructure and techniques are the main pain point of the entire supply chain, I think, at this moment. It's even bigger than NPM and PyPI. People are becoming aware of NPM and PyPI problems and other package repositories, but GitHub Actions are the most prolific way to spread supply chain attacks across different ecosystems. And I don't see a quick solution for it because nobody is doing it right. And there are a lot of people trying to explain how should we do, but because it's so configurable, so it's made to be configurable so you could adapt it to your workflow needs. And that makes it so exposed to vulnerable, how should I say, vulnerable vulnerabilities
Components,
and
right.
vectors.
Right.
Yeah.
It's basically a trust-based system, right? There's
Yes.
the assumption
Like
in
any open source repository,
right.
but here you don't
Right.
have a central repository where you can see number of downloads and similar stuff. You're just using it based on pure trust. No, you don't even have the popularity and similar stuff to handle
Right.
you in deciding which stuff to use. So, and
Right.
again, you want to be able to have a broad control of your CI/CD process, and that gives a lot of space and control to attacker if they manage to compromise your CI/CD workflow.
So would the use of version pinning have prevented you from being compromised in this attack? And if so, why would folks not just default to that?
Yeah, that the best way to be protected is to have version pinning and cooldown period. So take a few days before new release is published and don't update. Don't use that version if it's fresh, like less than 48 hours. Perform version pinning. Don't use carrots and tags like in GitHub Actions. Do hash pinning in GitHub Actions and do version pinning in NPM, PyPI, and other package repositories. Those are the basic hygienes, like washing your hands before you eat. So that should be.
Is there a cost to version pinning for companies that are, obviously heavily
The
reliant
whole
on open source? Yeah.
version maintenance becomes a bit more complex, but given the scope and impact of the recent supply chain attacks, I think that definitely you should use version pinning instead of blindly updating, because auto-updating is exposing you to huge risks. I say those are popular packages. You have Axios compromise, which is one of top, I don't know, the most popular package in NPM ecosystems for use with networking and similar stuff. You need to protect yourself from such compromise. There is no more trust model based on popularity. Okay, this is a very popular package. I can trust it and update it by default. No, you don't know which popular package will be compromised tomorrow, today, perhaps as we speak.
Right. It does seem like kind of security and security adjacent tools were targeted in this attack. Check marks and so on. Why is that? I mean, is there a reason for that? Targeting a vendor like check marks. For the malicious actors. What's the advantage there?
Well, Well, I think okay, they are scanning all your CIDC workflows, and you can expect them to be highly privileged actions, and they have high provisions. That's one aspect. Another aspect
Right.
is perhaps that threat actors were trying to send a message, either political, or some social, or however you name it. There are multiple aspects, but definitely one is because you can expect security tools to be highly privileged tools, and you would likely have them under your control. And nobody, and your, let's say, malicious behavior can easily be passed as the legitimate behavior of security tools, while not so easily passed like security behavior of some other tools. So that's an
Right.
old trick, hiding yourself in security tools.
And as we saw with the campaigns Lucia and Petar talked about, these attackers are taking extra steps to avoid detection by dependency scanners and other supply chain security applications. I think there was they use a particular, I think, path file or PTH file
PTH
here.
file, yeah.
Yeah. That was designed to kind of avoid detection. Can you just talk a little bit about that and what again, development teams should be doing to account for those types of attacks?
Basically, what's interesting, we had before the Light LM attack, there was like week before malicious actors, threat actors were experimenting with that techniques. We observed several malicious PyPI packages using the same technique. Well, basically, every day you encounter some package using some new technique, and you don't at that moment see that as the whole potential impact of that technique. And basically, it's hard to expect that any regular developer will be aware of all the various techniques threat actors already have at their disposal, or will come up in the incoming time period. So basically, they are always one step front of the defense and the victims. So, but the best way is to use security tools which are developed by professionals who are continuously tracking and improving those tools to cover the newest techniques attackers are using. But you can't expect to know. The goal of the threat actor is to find something novel that nobody is expecting, and it will always be one step in front of them. So use security tools.
So when you dug into what modules, what open source packages were affected by this, the numbers of downloads and the widespread use of this was kind of mind-blowing. Hundreds of millions of downloads. Yeah. So do we have any idea or sense, now it's been a month or a month and a half since this happened, what whether there's been any follow-on incidents as a result of this? In other words, okay, we've seen this incident happen. That is probably a consequence of the Team PCP, attack. Or do we have any sense on what the consequences were?
Well, basically, there is already a lawsuit against one major company that you can find that in open source intelligence. I won't name them here, but basically there are direct impacts already seen, which have legal consequences regarding the Light LLM compromise, which was basically caught by Trivia. And there can be expected to be many more of them to follow up, and they are also based on information from dark forums and similar stuff. They already have several big names being on their target based on the collected information stolen from these attacks. So we can expect a lot to come in the incoming months. I think the primary motive for them will be financial gain. So you can expect some ransomware or some extortion based on the collected data. So
But like as a development team, if you're looking at components like Trivy, Light LLM, check marks, and saying these are no longer, we can't assume that these are trustworthy because we've already seen they could be exposed to
well,
some
basically,
supply chain. Yeah.
that's hard. from my experience, when company encounters such event and gets compromised, they truly try to significantly improve their process and become better at it. So from one perspective, okay, they weren't trustworthy before, but perhaps now they'll do more about it than the competition. You have SolarWinds, which invested a lot of money and lots of effort to improve their security after a security incident. So if something happened earlier, you can look at it, okay, they weren't doing enough then, but if you see their follow-ups and look, you can judge if they now significantly improved their efforts. In most cases, when you get wiped on, you will be smarter and do more next time. So it would be unfair to say you shouldn't try that.
Is there anything development organizations can do on their end to sort of account for the fact that, you know, some campaign like this Team PCP campaign is almost certainly going to happen again, right? What can we do as a development organization to maybe put up an obstacle or a wall to, you know, like you said, protect us from that initial,
based on the latest month, I can tell to everybody this is going to happen again. If you are dealing anything with cryptocurrencies, you are the main type of targets. If you are just a regular developer, you are likely the collateral damage you will be. If you're a development organization, you need to start handling OSS supply chain risks. There's no way for you can afford to yourself to tell this is happening to someone else, I likely won't be there. No, this is happening to everybody. If you're using open source software, you need to handle open source risks. Start employing dedicated tools to protect yourself. Start applying basic hygiene if you are not willing to pay for tools or use free tools. Start doing, as we said, version pinning, dependency cooldowns, disabling post-install scripts and similar stuff. There are a lot of things that you can do for free, but always I would suggest you use dedicated tools because there are security professionals who regularly monitor, and you will be fast to find out if something is malicious and you are infected.
Okay, let's bring Lucia and Petar back just for a little wrap up. What are our closing thoughts here? What do we think the next few months are going to bring us in terms of these types of campaigns and threats? Do we see any clear trends? Oh yeah, we're going to see more of this. We're not going to see as much of this. What are our thoughts?
So I think because there has been since last year, there has been a rise number of supply chain attacks, high impact supply chain attacks. I think it's also safe to assume that probably they will happen in the future. You know, in the last month, we have seen a couple of them. Probably we'll also see, because of the stolen credentials from the previous attacks, we will probably see the new attacks that are just continuation of the previous. We also will be seeing, which we didn't mention, I didn't mention the Ghost campaign. All those packages were probably written with the help of AI. So with the rise of AI and everything, I think the number of NPM packages, not just malicious ones, but in general, rose. So I think with the AI, malicious actors are faster and can write malicious code faster. So probably we're going to see even more malicious packages. Yeah, basically. And probably in the future, they will continue into making those high sophisticated packages, high sophisticated GitHub repositories to hide their
Lucia, when you say you've seen a lot
go under the radar, basically.
Yeah, when you say you've seen a lot that appear to be written by AI, how can you tell? What are some of the signs that, oh yeah, this is probably AI generated code?
So I'm not completely sure. Of course, that there is no completely definite proof. But a lot of code that I have started seeing have a lot of comments and specific AI comments. So basically, if you ask Gemini or some other tool to write you a code, Gemini would give you the code, but would also give you some comments that explain the code step by step. And a lot of the packages I have seen in the last couple of weeks have those specific comments that are explaining the code. I mean, always developers are leaving comments explaining the code, but these ones are like wordy and very specific, I would say. I don't know how to better explain it.
Right. And as that bar to code creation goes down, right, the volume of code is almost certainly going to go up. Let's just move to the best practices slide, and let's just talk just really quickly. We've got a couple minutes left. Our recommendations for, what types of guardrails we might be able to put up going forward. I don't know, Carlo, Lucia, Petar, anything here in particular that you want to really single out for our viewers as to things that they can do that would really, increase their protection against these threats?
Well, from my perspective, definitely the point validated trust. Basically, lots of people are taking it, okay, this is popular, I can trust this. That's the biggest mistake you can do as a developer. Popular maintainers on open source are not funded usually. They are doing it from a hobby, and they are humans like any of you, and they get fished, they get anything, and it's no blame in getting fished or anything like that. But you just need to know that if something is popular, a lot of people is trusting it. It doesn't mean it is bulletproof, and the next version of of that package software should be trusted. Always, you can trust something that was published 5 years ago. That would probably be okay, but don't do auto upgrades and auto dependency updates, because new versions, any package, the one with most downloads, can have a version published in 5 minutes, which is malicious. It can get compromised. So,
and we've seen that. We've talked about that and written about that, of seeing, packages, tools that are put out there, maintained for 6 months or a year legitimately, and then flipped to become malicious.
I'm not talking about that. I'm talking about, for example, the Axios package, the biggest incident in this month. So basically, it is really popular, it's trustworthy, and it got compromised. Chuck Debug and everybody else in last year. There was dozens of them in top 10 MPA packages.
Right. And as you said, the Team PCP, that started with compromise of developer credentials and access through that. So, I mean, a lot of these
cascading effect.
Right.
You always have to take.
A lot of these start at layer 8, as they say, right? With human beings behind these projects. Okay, cool.
And start using dedicated tools to check for.
Yep. Okay. Just moving on. One resource definitely you should take a look at is the Spectre Assure community, right? This is Carlo, you just want to talk briefly about Spectre Assure community and how developers can use that to be able to improve the security of the code they're working with.
Well, basically, you can check manually on the website, but there are also free amount. There are several pricing options, but you have a free tier for anybody who likes to do APIs, and they can programmatically check for dependency they are planning to use their projects. We are planning on releasing new integration for various developer tools, which will aid in, let's say, Visual Studio Code extensions and similar stuff that can help you programmatically, or like a tool from your IDE to check dependencies you plan to use in your project, or IDE extensions like VS Code extensions to check their validity and software quality and dangers.
We have a question. Is the community version of Spectre Assure package scanning only available from secure.software?
Yeah, as I just said, there are APIs, and you can register for free tier and use those APIs. You have some amount of traffic you can generate before needing to switch to the paid one, but that one part is for free, and they can be used from programmable approach.
Okay. Okay, thanks everybody for joining us, and really great conversation. Thanks, Carlo, Lucia, Petar. We'll do this again. We've got some other great talks coming up, and also on demand at our website. So go check out our resources page. But coming up, we got Secure Software Approvals Faster with Stuart Phillips, coming up in about a week. And then we've got the Intelligence Foundation, Raw Indicators, Lifecycle Driven Intelligence coming up end of the month. So check that out. And again, thanks everybody. We'll be back in Q2 looking at the research from our second quarter. And thanks again to Carlo, Lucia, Petar. It's been great. We'll do it again.
Thank you. Bye.
Thanks, bye.
Bye.